Show you is that when you are taking the distance, when you're trying to take the distance of an object, or the distance between 2 points, there's a couple of different things that you can do. There's a couple of different things you can do. Remember, the main generic thing is the straight formula, where you're doing the change in x values, adding that to the quantity squared, the change in y values. But remember, all that is, it's just another way of writing this. It's just another way of showing Pythagorean theorem, where your a squared is your distance, your change in x, where it goes left and right. Remember when we used that triangle means change? It just means how far apart they are. How far apart are the x values? Same thing with the b. That's just how far apart, how far apart are the y values. When you did that, you squared both of them, added together, and you took the square root. It was really, and I think most of you guys saw that, it was really easy just to count and to go through it that way, as opposed to writing out the whole formula long form. So distance is always going to be written like this. Distance of AB. How far apart are A and B? You'll see that little D out in front, something like that. So if I want to say how far apart A and B is, where A is -3 and 0, I'll make it -3 and 8, and B is -7 and 4. Do I need to utilize the formula, or can I just think my way out of it? Well, by now I hope you guys realize that thinking your way out of something like this, whether it's distance formula, midpoint formula, or even find the missing endpoint, you can think your way out of just any one of those. It's just a matter of, do you know which one are you working with? So whenever you see the D, you're working with distance. So how far apart is -3 and -7? 4. Do you worry about it being negative? No. What's the only, of those three things, distance, midpoint, or find missing endpoint, which one of those do you worry about negatives? The missing one, because that way you know if you go up or down further. This one we don't care, because you're changing x values, it's just some distance. You walk the distances, it doesn't matter. So it was 4. 4 squared plus, well, how far apart is 8 and 4? Oh, you realize I did that same thing number. It's also 4. So you get 16 and 16, which is 32. Press the buttons on the calculator and you get dun, 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 √2. What's that? Look, it's middle of September, and I've been telling you guys you could have gone to the store at any point in time. You can't rely on us to do everything for you. I'm sorry. I'll take your money, but I'm sure you've been to a store that had them. And I know you said, oh, I hate Walmart. Well, I do too, but could have gone to Office Max. Is it Office Max or people? Whatever. Target, Farm Fleet, Kohl's. It's other things. Now, people have asked, if you don't have that calculator that presses that button, how do you simplify that? Well, you have to know what's actually the square root means. Square root means you're looking for two numbers that are exactly the same number that are hiding within it. What you're looking for are what are called perfect squares. Perfect squares, for example, are 4, which is 2 times 2, 9, 3 by 3, 16, 25, 36, and so on and so on. What you're trying to do is say, hey, can I take 32 and divide it by one of these larger perfect squares? Well, I can divide 32 by 4, but can I also divide it by 9? Can I divide it by 16? Yeah. So just like you could write numbers as composites of their, remember prime writing things as primes. When you do factor trees, if you had like 12, it would have been 3 times 4, which was 3 times 2 times 2. Remember doing that? This is basically the same thing, but instead of just going down to prime factors, you're writing it as perfect squares. So this would factor to become the same thing as square root of 16 times the square root of 2. So that's why you get 4 root 2. That's what that means. That's how that works. Instead of doing prime factors, you're looking for perfect square factors. Okay? And I know you guys all did that in your Algebra 1 classes, just been a little bit of time since you've done that. Ooh, you got the battery operated one. That's the fancy one. Do you know they make like a gunmetal gray one with like silver buttons? It's pretty sweet. Mr. Fontana has it. It's pretty cool. So, excuse me, that would be distance. Now the difference between seeing distance versus midpoint, what are you doing with midpoint then? Find what? Find the middle, right. You're trying to find where is the middle of it. So we had, where's the middle? Okay. Now, midpoint is the one that you have to divide by 2. Midpoint's the only one that you're dividing by 2. So we had the ordered pair a second ago. A was what? -3 and 8. B, was it -7 and 4, I believe? So if those are my 2 ordered pairs, remember all you're doing is you're finding the average, if you want to think of it that way. You're just adding the x coordinates together, cut it in half. Add the y values, cut it in half. But I cannot stress, if you're doing this in a calculator, make sure you use that fraction bar. Because if you don't, if you take -3 plus 7 divided by 2, it's going to be wrong. Because it's going to divide by 2 and then add it to the -3, and it won't work. All right. So -3 and -7 is how much? It's -10. So what's half of -10? 5. Okay. You do the same thing with the 8 and the 4. Well, what's 8 and 4? What's half of 12? There's your ordered pair. Okay. Make sure you don't use the, don't do it all at once. You have fraction bar on that one? Make sure you use fraction bar. That's usually the type of calculator people screw up when they'll write 8 plus 4 divided by 2, and they'll write 10. Because the calculator is just 4 by 10. Now, remember, midpoint's the one that divides by 2. Where's the middle? And then what about missing endpoint?
You just count.
Yeah. Missing endpoint's the one where you just count. Where if segment if B is midpoint of AC, where is point C located? That's the one that you count. Okay. So if you're trying to find the missing endpoint, that just means you're counting up, counting down. So missing endpoint, if I have -3, -7, you count up or you count down. So going from -3 to -7, you going up or down? Down. How many? It's 4 less than -7 then. -11. Okay. So it'd be at -11. And then from 8 to 4, are you going up and down, up or down? Down. How many? What's 4 less than 4? Sure. Missing endpoints are the quick ones. That's the easiest of them all. Just count up, count down. That's all you do. Yes, sir. No, I'm doing some review stuff right here. I don't have it packed in 3 seconds. But I got a couple problems that I know would be good ones to look at for tonight. Good question. Anything else? That's actually a really good question. A lot of times with the review stuff, I don't necessarily have like big packets and things for chapter tests and whatnot. What a lot of times I do is I'll pick specific problems and stuff out of the book and just have you guys do it that way. One thing I will warn you though is that historically, chapter reviews, you know, things that I usually assign right before tests and whatnot, those are usually the assignments that most people don't do, which means most people don't study, which means when that happens, it's pretty obvious who prepared, who didn't prepare. So let's do this real quick. What I want you to do is take X, what I did here is I threw up a question about, I gave you two ordered pairs, x, y. I want you to do three things. Find the distance of it, find the midpoint of it, and find the missing endpoint z if y is a midpoint. Does that make sense? I want you to try all three parts real quick and we'll check in a couple minutes. All right. Does. So distance-wise, when we start out with the distance, guys, remember, all we're trying to do is find what's the horizontal change between 3 and a negative 5? The horizontal change is just 8, so it becomes 8 squared. The horizontal change between the negative 4 and the 6 is 10. So we square root the sum of those two squares, and you get 164. And we take the square root of it, and it was what, 2 root 41? Does anybody else have just the graphing calculator, the old 73s? Is anybody else using that one right now? You're special. Here. The rest of you guys have to do long one. At least there's a little bit of shortcut for that. Okay. We're okay distance-wise?
Yeah.
Midpoint. Midpoint, we're just adding together and cutting it in half. Find the average. So what's negative 3 plus negative, I'm sorry, positive 3? Yes, ma'am.
I have a question. Where did 8 and 10 come from?
How far apart is 3 and negative 5?
Oh, okay.
What's 3 plus negative 5? What's half of negative 2?
Is that 164?
Yes, ma'am.
Another one.
Ladies and gentlemen, come on. What's negative 4 and 6? 2. What's half of 2? 1. So there's your midpoint. My midpoint is at negative 1 and 1. And then lastly, if I'm working at it, what? Again, I'll show you long form because it's 3 plus the negative 5 in half, negative 4 plus 6 in half. So you have negative 2 over 2, which is negative 1, and 1. That's how that works. All right. And then lastly, if y is the midpoint, how do we get to z? So going from 3 to negative 5, did we go up or down? We went down. So if I went down to negative 8, what's 8 less still?
Negative 13.
And then from negative 4 to 6, we've already said we went up 10.
16.
And then 16. Good. And then you're done.
Is this like how the questions are going to be set tomorrow? Like you have distance, midpoint, and the missing all together?
And they might be 3 separate questions. They might be 3 different parts. They might be 3 different.
You know.
Of course I know. I'm not
You
gonna tell
say,
you.
well, you can't say I don't know. You just gonna say it. I'm not gonna tell you.
Yeah, I know.
Well, it's more fun to say, I don't know.
No, it's lines.
Maybe I haven't finished writing the questions.
Nah, I'm pretty sure you did, because it's tomorrow.
I know. I change my mind on the questions a lot. I reword things. You know, nothing's set in stone until I press print. Let's see.
Can we retake it again if we fail?
So the other part that we talked about, going back into 1.1. Going back into 1.1, that was a lot about diagrams. How do you label things? Things like that. For example, if I say I have ray AB, how do you draw ray AB?
A dot and then an arrow.
What do you put at the dot? A. Why is it not B?
That's where it's like starts.
The arrow part. Good. Since guys, since A is the first letter for array, it's the starting point. It goes through point B. Now, does it matter where you place B? Can it be to the left of it, can it be to the right of it, can it be to the left of it, above it, below it, anywhere. It can be anywhere, as long as B is the point that's going through with another arrow. What about, how do you do this? Point C is between D and E on D, E.
It's a
That's all it
line.
is?
It's a line segment and then the point in the middle.
Yep. Does it matter where you place C to one side?
No.
No. It could be anywhere, as long as it's between it. That's what it looks like. Now, when we did those, we did a bunch of stuff like that. That allowed you then to do segment addition. Two smaller segments added up to equal the whole. Okay. That was one of the first things we did with a little bit of the algebra. And that was all, let's see if I have one more button. We have this, where you had a segment addition style problem, that it told you that J is between H and K on K.
I still remember this.
It didn't have a diagram, which means you had to draw a diagram. When we did this problem before, we just drew the segment, labeled the 3 points, and filled in the blanks.
So this is also part of the quiz tomorrow, like.
This is section 1-2. We're doing
Okay.
1-1 through 1-3, so
Okay.
maybe fill in the blanks. Okay. 5x minus 3 and x minus 9. Did I put a W? And both things. So as you do this, we know, hey, we know that small segment plus small segment has to equal the whole segment. It's just a matter of piecing it back together algebraically. Now, I had a lot of people freaking out with this algebra again last hour. I don't know why.
You forgot?
Probably. Obviously, on the left-hand side, yes, obviously on the left-hand side, you have to combine like terms. What's 5x and an x?
6x.
6x. Dun, dun, dun. Variables on both sides of the equation, click on the little guy. Subtract the 5x, and I'm going to add both at the same time. What's x? Done. Now remember, a lot of times with these types of problems, it's not just solve for x. Sometimes it is just solve for x. Other times it's solve for x, but then they'll ask you, what is kh? So you take that value and have to do what? Yes. So if I want to figure out what kh is, what would you have to substitute in? Oops. Which one do you put 12 in for?
5 times 12.
Yeah, that's it. KH segments here, and you get 60. Okay? Now the difference between two smaller segments equaling the whole versus midpoint is that midpoint, that means each part is equal to each other. Notice, I didn't set anything equal, I didn't say 5x minus 3 equal to x minus 9, because this doesn't say that. It never in there said anything about midpoint. It didn't show in the diagram that you had tick marks that they were equal to each other. So the difference between that versus is going to be pretty evident. If I look at one like this where it says find MR, well, in this case, if you look at your diagram, automatically you have two segments that are equal to each other because of those little tick marks. The tick marks mean that they're congruent. And when things are congruent, they have equal measure. So this algebraic style problem, you have to set them equal to each other. It doesn't say how much the whole thing is. It just says this much is 4x minus 12, the other one is negative 2x and 21. So pick on the little guy. Who are you going to move?
-2.
The negative 2. How do you move a negative?
Add it.
Add 2x. I'm going to add 12 at the same time. I have 6x is 33. And then divide it by 6. You get 11 over 2. 5.5. But remember, it's not just 5.5, it's asking to find MR. So if you have 5.5 and you double it, what do you get? If you double 5.5, what do you get? 11. But it'll be negative 11 because it's negative 2. What's negative 11 and 21? It's 10. Check the other side to make sure you didn't done goof. If I double 5.5, what did you get? We got 11, didn't we? If I double that, what do you get? If I double 11, what do you get?
15.
Okay, you get 22. So 4 times 5.5 is 22. What's 22 minus 12? Wow. It'll be a fun one tomorrow, guys. Come on. So obviously we have midpoint and midpoint to work. Vocab is hard. Okay. Not a lot going on here, guys. We should be able to keep up on this vocab here. And that's one of the things that people are going to mess up. You got to read things carefully, knowing when to use what. It's not like a matching section of vocabulary. It's knowing how to use the terms. Okay? What I have for you guys to work on tonight, which I'll collect for the quiz tomorrow, is in the book. And it starts on page 64. Now, there's been a little bit of questions about which page 64 are you looking at? Well, the page 64 that I'm looking at is the actual page 64 that you see on the bottom of the page number. Like right here, where it says 64. Well, here's the thing, and this is where people are getting confused, and you're right. Where people are getting confused is that what happens when you click on the geometry book. Shh. Mackie, would you get the light for me, please? Thank you, ma'am. What happens that people are getting messed up on, if you look at where it says, where we click for the textbook, shh, guys, come on, I don't want to have to show you this again. It shows up as this is page 1 on the bottom part here, when really it's not page 1. Yeah, you have to scroll through a little while to get to the actual. So if you look here, it says page 80 in the black box, but yet it's page 58. So they're off. Don't go by these numbers down here. go by the textbook number page, and that's what I'm trying to get at. Most people forget that. So what I want you to work on tonight is going to be on page 64. I want you to do numbers 1 through 13. Okay? Let me do this again. And then we'll have our quiz tomorrow. We'll collect this right off the bat. I'm assuming that the quiz itself shouldn't take you more than 25, 30 minutes tops, but I'm not going to start the next session, even though we could get through it rather quickly. No reason to double up on that. Nope, that didn't show up at all. There we go. So if you want to take a picture of this, go for it, or you can pull it up in your book. I'll leave that here, and we'll go from there. All right? It's on page 64. It's all calendar.